Hello everyone, in this video we will see the circle detection using OpenCV half circle transform. So we will detect the circles in an image. Now as you can see here, I have this small example which loads an image and shows it into the I'm show window. So let me I've already run this code which will show a simple image without this the big circle. So uh, so so all the smarties of this image of the circle are not in the right form, so they are not in the perfect circles, and we want to detect all these circles forms inside the image. We can use the half circle transform for that. So let's see how we can use this half circle transform to detect the circles in the image. So for to detect this circle, we will represent it mathematically by the equations, which is the x center and the y center are coordinates of the center, and the r, which is the radius of the circle. So if we know these three parameters, that you can draw a circle, are the coordinates of the circle and the radius of the circle we need to detect. So now let's see how half circle method applied using OpenCV. So you might observe here that I have created a copy of the original image which I have. Using this, I am a read method. In the next step, I am going to just convert this into a grayscale image, which we will just write gray, which is equal to the cv.cvt color, which will take the two parameters. First is the source and the second is the method. So we are going to convert the color bgr. uh, in the next step, because our half circle method works better with the blurred images, so we are going to create these blurred images using the median blur. So I'm just going to say gray. So we are going to override this the gray variable with cv2 dot median blur, which will going to take few arguments. First is the image itself, so we are going to pass the in gray here, and the second is the key size or the kernel size. So we are going to initially provide the kernel size, which is the 5. Here now we are going to apply our half circles which method, which we are going to declare this circle which is equal to the cv dot half circle, and then I'm just going to call this method which is called the cv dot half circles. So this is the method, and you can just see it takes the few parameters which we are going to give this parameters one by one. First is the obvious one, which is the image, and we are going to provide the grayscale image here, which is already blurred. So the second parameter here is the method which we want to use. The currently the only implemented is half gradient method. So the choice is very simple. We are going to just write the cv dot half gradient method. The third parameter here will be a dp. DP is the inverse ratio of accumulator resolutions to the image resolution. So, for example, when the DP is equal to the accumulator has the same resolution as the input image, and if the DP is equal to the 2, then the accumulator has the half as big as width and the height. So, we are going to take this DP as value as 1, and the next parameter here will be the mean distance, which is the minimum distance between the center of the detected circles. Okay, so here we are going to just give initially of value of 20, and later we will adjust the value if the circles are very near to each other. And the next parameter we have the param 1 which is equal to 50, and the parameter 2 which is equal to 30, and the mean radius as 0 and the max radius as the 0. To for that which we are going to say anything which is greater than 0. So it returns center without finding the radius, so this is also going to start with 0. So this half circle method gives us a circle vector which we can iterate upon. The first of all, we need to convert those circle parameters which we got using this circle variable, that is the x and the y coordinates, and the radius into the integer. So to do that, we are just going to just declare a parameter detected underscore circle which is equal to the np dot numpy to pass our circle parameters which we got using the half circle method. Now in the next step we are going to iterate those over those details which gives us the x, y and the radius. We can directly just asterisk, just say x, y comma and the r coordinates to detect our circle, and those will index as 0 column, and then inside this for loop. First of all draw the circle and then we will detect it. To detect these circles we are going to draw the center. For this we have the circle method available which takes a few parameters. After that we have used the IMSO function to cut. So I have already in this code we have used the IMSO function and also the wait key function and the destroy all windows. While you running this code we have got the one output which will in which we can see this dot is first of all run on each circle which is detected, which is in the form of black color and also in the form of different colors if we will detect. And you, as you can see, this circle is drawn, so every circular shape is and you closed by the detected circle. We also strangely detected that this circle somehow, because OpenCV, as we think that this is also a circle which I have detected. So that's all from this video. Thanks for watching.